At this stage, you should be able to go from equation to graph or look at a graph and recognize the equation. We are looking at first order, zero order, and second order in IB. If you have zero order decay, meaning that if you have a reactant A that is being consumed to give you product, if it's zero order, you start with A0. For example, you have 8 particles, and linearly you decline until you get to 0. And this is how the sort of graph of concentration of A versus time looks like. And these are segments of half-lives. If you look at the first half-life, after 8 particles get consumed to 4, this is a point that we call half-life. So this is T half or half-life. Now for zero order, the second half-life, when the 4 particles now becomes 2, if you look at it, the second half-life is much smaller than the first one. We are looking at the segments of X to compare, and gradually the third half-life even gets smaller and smaller and smaller until you have no more reactant A left. Now what is rate versus concentration of A? So remember, anything to power 0 is 1. So rate versus concentration of A is a flat line, and K, this is magnitude of K, whatever your K is. For first order, now the decline is no more linear, it's rather exponential. So if you start with 8 particles, after you have 4 particles, this is your half-life. And then after 4 becomes 2, this is your second half-life. And if you look at the segments of half-lives, it's exactly the same. So that's an indication you're dealing with a first order decay. And if you look at the rate versus concentration of A, it looks like an equation of straight line, and K is your slope. It's like mx. So the slope of this line, this is a linear. You start from a number or 0, and this is your slope, which is equal to K. So that's indication of first order. If we look at a second order, it will decline. A will get used up, but it's no more smooth like first order. It's much closer to your axis, the regression or being consumed. If we have 8 particles at beginning and then 4, this is your first half-life. Now you see the second half-life gets much larger than the first one, and the third half-life is even bigger than the second one. So that's indication that this is a second order graph rather than half-lives being equal. So this is how a second order gets consumed as time is elapsing. Now what is rate versus concentration of A? It's a parabola. So this is what you have, because it's like 4x squared, 5x squared. So that's your x squared, how it's changing your y-axis. You can remember it like that. Now if you want a straight line, all you need to do is plot it versus a squared. Then you get a straight line, and then this becomes slope k. So you should be able to go from graphs to equation and recognize what order it is. You should also be able to draw the rough graph if you have the equation.